A warm good evening to one and all present here. So I welcome you once again to the NPTEL live session for the course Advanced Concrete Technology. It's a week 12 problem solving session. So let me share my screen. So in the past weeks we have seen about cement chemistry and composition of cement, how to manufacture cement and what is the raw materials in it, and then we have seen about the fresh properties of concrete, hardened properties of concrete, how does the hardened properties of concrete can be improved, and then how does the addition of mineral admixtures, chemical admixtures could benefit the application in concrete industry. And now this week we'll be seeing about the durability of concrete, and last week also we have discussed about durability of concrete. So this week we'll be seeing the problems from week 12 content. I hope you guys have watched the video. Let me check once as the recording is started. Yeah, the recording is already started. So let me make it a full screen mode and then we'll see the questions. So I request you guys to give your answers in polls. So to the people who have joined new, let me explain once again. So to the bottom right corner of your screen, there is an option called activities. It is square, triangle, and the circle together. If you click that, there is an option called polls. If you click that, you'll find the questions. Or as if you're using a mobile phone, there will be a three dot in your screen. If you click that, you'll find the option called activities. From that, you can click the polls. Okay. So now, once we discuss your question, one after the other question, then you can give your answers in the polls. If you're unable to access polls, you can give your answer in the chat box. Okay. So now let me get back to the PPT. I'm Nilakanmani. I'm a PhD student doing my PhD in IIT Madras. So I'm one of the TAs for NPTEL TAs for the Advanced Concrete Technology course. Now let's get into the question 1 for this week. So question 1 is a true or false question. Most of the questions I've launched here is true or false question because I find you guys mostly answer for true or false questions. I've just kept it these kind of questions for this session. So the question 1, let me read out and start the timer. So the question is, steel embedded in uncontaminated concrete does not corrode due to low pH of the concrete pore solution and formation of layer of initial corrosion products on steel. Okay, if you find the statement correct, then please pick true, and then if you find the statement is wrong, then you can pick false. Let me start the timer for a minute. Then after a minute, we'll see what guys you have answered, and then we'll see the solution as well. In the meantime, if you have any query, please stop me by any time and ask the query. If it's relevant to the question, it's fine. If it's not relevant to the question also, I'm ready to answer. If I'm not sure about the query, anyway, we have one more live session next week because I've skipped one of the live session for week 2 content. So we'll have one more live session next week on Monday. To make the question simple, steel embedded in uncontaminated concrete does not corrode. Up to this statement, it is correct. Okay, it's a correct statement. But after that is the reasoning for the statement given here. So you have to find whether the reasoning provided in the second part of the sentence is valid or not. Okay, so the time has already gone. So let's see what answers you guys have given. Okay, 2 votes for true and then 1 vote for false. Let me check the chat box as well. Okay, most have given true. Let's see the solution. So as I said, the first part of the sentence is true. Yeah, that's valid. Steel embedded in uncontaminated concrete does not corrode. That is right. But the reasoning given is not true. Okay, because low pH of concrete pore solution, that is not right. Concrete pore solution, if it's uncontaminated, then the pore solution pH is pretty high. It's in the range of 13. Okay, so which helps in the formation of a layer of initial corrosion products, which acts as a passive layer and protects against further corrosion. Okay, so the statement is false because only one part of the statement is true. So overall the statement is false. Okay, so now let's move to question 2. I hope you guys got it right. So moving to question 2 is going to be an assertion reasoning type of question. So statement 1, and in assertion there will be one statement, and in reasoning there will be another statement which is given as a reasoning for the statement given in the first statement. Okay, so that's mean as assertion. Assertion is marked as A and reasoning as R. Okay, let me read out the statements. Assertion is carbonation leads to increase in pH due to reaction with Portlandite. Okay, so the reasoning given is cementitious systems with SCMs show higher carbonation depth because of less Portlandite and coarsening of pores and increasing in porosity. Okay, so let me start the timer now for a minute. So you have to find whether assertion and reasoning both are correct, and then reasoning is the correct, R is the correct reasoning for statement A, then you can pick A. If R is not a correct reasoning, then you can pick B. If you find A is true but R is false, C. If you find A is false and R is true, then you can pick the D option. If both you find it's wrong, then you can pick option E. Please read out the statements clearly. If you want an extra time, I can give you 30 seconds extra time. Please go through the statements properly. Time is up. Let me start the timer for 30 more seconds. I've given another 30 seconds of time, so let's see what's the class response now. A is true but R is false. Okay, someone has picked option A, which means both is true and R is the correct reasoning. Okay, let's see. From the polls, okay, people have picked option C and D. A is true but R is false. Someone have picked A is false but R is true. Okay, let's see what is right now. What is the correct option? Anyway, any one option is going to be correct, not both. So the correct answer is D. A is false but R is true. Let's see what's the reason. So carbonation leads to decrease in pH, not increase in pH. Okay. So when Portlandite reacts with carbon dioxide, forms calcium carbonate. That you guys know, right? Calcium hydroxide reacts with carbon dioxide to form calcium carbonate. So that causes decrease in pH. So unless Portlandite is already there in the system, uh, if Portland is there, if Portland is there in the system, then obviously your pH is going to be pretty high. If it carbonates, there will be decrease in the pH. So if you do accelerated carbonation test, and if you check for the phenolphthalein indicator test, then if the pH is less than 9, which will be indicated by a colorless. If you spray phenolphthalein, then if there is a pink color indication, which indicates a concrete part is not carbonated, and if the colorless indicates it's carbonated. So which indicates a decrease in pH when concrete is subjected to carbonation. And moving to reasoning, cementitious systems with SCMs has higher carbonation depth. Yeah, that's true, because there is less availability of Portlandite, because the reactive alumina from the SCMs react with the reactive silica from the SCMs react with the Portlandite to form additional CSH, and then there will be coarsening of pores as well, and then there will be increase in the porosity. So further the carbonation depth increases with cementitious systems with SCMs. So option A is false and A is false and R is true. Now moving to question 3. So this question is directly from the what is that? Practice questions, but I don't know how many of you have understood the question properly. So let's see this question. So if you know the answer, please give the correct answer, and also please type the reasoning why you feel so. So okay, so let me read out the question and start the timer. Primary ettringites are formed during hydration of cement. Okay, this is a statement, and now they're explaining the situation. But sample A and sample B, there are two samples, shows crack initiation after a few months. So if primary tringate is formed in the if it's formed when the concrete is in during the hydration of cement itself, when it's green, when the concrete is green, if ettringate is formed, then we need not see much expansion. But if ettringate is formed in the later stage, the hardened stage of the concrete, then we can see some expansion and it can cause cracks. Okay, so in here they are primarily saying primary ettringates are formed during hydration of cement. Then they are speaking about secondary ettringates. Okay, so but sample A and B shows crack initiation after few months, which means the secondary ettringate forms after few months, which causes crack. Which is an for understanding I'm saying it here, but it's not clearly explained in the question. So they are saying sample A is collected from a railway sleeper, whereas sample B is collected from surface of a sewage pipe. Okay, if it's a sewage pipe, you can expect what kind of reaction might happen there. Since you have already watched durability videos, you can expect what kind of contaminants will be present in the sewage pipe. And then coming to sample A, it's from a railway sleeper, so obviously you can think how it will be prepared. Railway sleepers are n number. It's not one or two numbers. It has to be formed in n numbers to lay in the railway track. So just think how it will be prepared. So they're saying both sample A and sample B has cracks, and is collected from sample A is collected from railway sleeper and sample B is collected from the surface of the sewage pipe. So what can you say about A and B? Okay, so what is the inference from this? Okay, please go through all the statements and pick the correct answer. Let me start the timer now. And only one answer is the correct answer, not two options. Please give your answer in polls or in chat box. Time is up. Okay, let's see the class response. Let me end the poll for the previous questions. Okay, most of you have picked, only 2% have give your answer. Okay, but you have picked the right answer. There are around 10 people in the class, but only, okay, someone have picked option C here. Option C is the right answer, but not much people have given your answers. I request everyone to give your answer, even if it's right or wrong, that doesn't matter. Let's see how much you can able to understand the topic now. And it's going to be the last week also. Next week we'll be having one more live session on Monday. So moving to the solution part. Since most of three answers have been collected from this question, but all the three answers are correct. So since sample A is collected from railway sleeper, most in case railway sleepers are prepared from uh, uh, like it will be prepared with steam curing for faster to hardening for to fasten the process of concrete hardening. Normally they're prepared with steam curing. So the temperature of the concrete samples will be the temperature, samples, the concrete samples from railway sleepers will be subjected to high temperature, which can be even more than 70 degrees Celsius. So in such cases, we all know that ettringite is not stable at that temperature. So delayed ettringite formation can be one such problem from sample A, which is collected from railway sleepers. Coming to sample B, the sample is collected from surface of sewage pipe. So in such cases, there will be sulfate attack is possible, acid attack is possible. In such cases, extra sulfate will come to place, and then when externally sulfate comes into action, it reacts with the existing uh, Portlandite and then monosulfate to form ettringite in the hardened stage, which causes extra sulfate attack. So we can say that sulfate is penetrating from outside for sample B, forming gypsum and deteriorating CSH, whereas delayed ettringite formation is seen in sample B. Most of you given the right answer. Now let's move to question 4. So question 4 is again a true or false question. Let me read out the statement. The statement is carbonation induced corrosion is uniform, whereas chloride induced corrosion is localized. If you find the answer statement is correct, you can pick true, or else you can pick false. Let me start the timer for a minute. It's a very simple question. So if you know the answer, please give it in polls or chat box. Anyway. Time is up. Let's see the class response. It's a very simple question. Okay, most of you have picked true. That's nice. Okay, both true as well as false is there. Let's see. So moving to this is one of the diagram that is taken from the lecture. So more or less, carbonation induced corrosion is it's called general or uniform section loss. But when it comes to chloride induced corrosion, there will be localized or pitting corrosion. The section loss will not be uniform. It will be a non-uniform section loss. Because when coming to carbonation induced corrosion, most in case carbonation occurs with the carbonation induced corrosion means the pH of the concrete reduces less than 9 or 9.5. When it reduces less than 9, the passive layer formed over the steel surface is not stable at lower pHs. Then overall the steel rebar corrodes. Okay, it's not at a particular location. But when it comes to chloride induced corrosion, where there is a weak spot or where the concrete is porous, in such cases what happens, chloride can easily penetrate through that area, and then it can reach the surfaces and it can start corroding. Once it starts, it's like a continuous process with the availability of oxygen and moisture. So obviously when it comes to chloride induced corrosion, it is localized, or it's called pitting corrosion. So the given statement is true, it's not false. And moving to question 5. So here this is also regarding corrosion only. So the statement is availability of moisture and oxygen at anode is most critical, whereas it can be absent at cathode for corrosion initiation. I hope you guys know that when it comes to corrosion, anode is the part which corrodes. Okay, cathode is the part which is protected from which does not corrodes. So normally when we provide some protection against corrosion, we call it as cathodic protection, because cathode is the one which is protected and the anode is the one which is sacrificed. We call it as sacrificial anode as well. So here they are saying, let me start the timer. Here they are saying that availability of moisture and oxygen that anode is very critical, but it can be absent at cathode. Is it so? If you find it's true, you can pick option A, or else you can pick option B. So before seeing the class response, let's see the solution and see the class response. So the correct answer is false, because we know that there should be ionic conduction from anode to cathode, and then there should be electron conduction from cathode to anode happening. So in anodic reaction, what happens? The ion from the ion there will be an ion there will be an ion of iron forming, and with release of two electrons. That reaction will be happening in the anode part, so which is called oxidation reaction or anodic reaction. In the cathode part, what happens? So we need the supply of both oxygen as well as moisture, and with this released electron from the anode forms the hydroxyl ions, so which further takes which causes the corrosion process to continue. Okay, so we need both oxygen as well as moisture to be present in the cathode for the corrosion process to continue. So availability of moisture and oxygen at anode is not most critical. So the statement is false. Okay. So now let's see the class response and then move to the next question. Okay, there is some mixed response here. Okay, so now I guess with the equation you got it right, I feel. So now let's move to the next question. So it's going to match the following question. Please type your answer in the chat box. Okay, I have not launched this question in polls. So here the question, like we have to match the parts in the left side of the column to the right side of the column. So here there are three options. One is galvanization, corrosion inhibitor, and then three is stainless steel. Here there are three options: A, B, C. A is non-oxidizing passivators of steel. B is plating with steel with zinc, and then C is stable passive layer. Okay, so let me start the timer now for a minute. After a minute, I'll check the class response. If you know what is galvanization, then the answer is very clear. And what happens with stainless steel regarding corrosion, and what does corrosion inhibitor does to steel. So if you know these points, it's easy to pick the answer. Please give your answer in chat box. I have not launched this question in polls. Time is up. Let's see the class response. Okay, 1B, 2A, 3C. That's nice. Okay, option C, someone have picked. Okay, next let's see the solution now. Most of you have picked the right answer. So the correct answer is 1B, 2A, and then 3C. So the correct answer is option C. Coming to galvanization, mostly we plate the steel with the zinc. So that is called the galvanization process. So here the zinc acts as a sacrificial layer here. So galvanization helps with corrosion as well. So then coming to corrosion inhibitor. Corrosion inhibitor, what does it does to the steel is it is a non-oxidizing passivator for the steel. So it acts as a like when it comes to corrosion inhibitor, it prevents corrosion in many ways, and we can say that it's a non-oxidizing passivator for the steel, which protects the steel against corrosion. And then coming to stainless steel, it has a stable passive layer because its elemental composition has different elements like chromium in it, so which prevents the steel against corrosion. Okay, so now let's move to question 7. And then question 7 is this question is particularly from the lecture. If you have watched the lecture videos, then the answer is very simple. So from the lecture, mention an approach suitable to mitigate evaporative transport and then sulfate salt crystallization. Here the question is very direct. They are asking for an approach suitable to mitigate evaporative transport. Okay, and then sulfate salt crystallization. Okay, let me start the timer now. Something happened to my mobile phone. Let me start the timer from my watch. Let me start the timer for a minute. Yeah. After a minute, we'll see the class response and then solution. Time is up. Let's see the class response. Was my screen visible? Okay, I hope it's visible. Okay, most have given the right answer. Let me check the class response from here as well. Yeah, most have given the right answer. So, this question is direct from the lecture PPT. So, in which sir has discussed about how we can like reducing the water to cement ratio of the cement mortar to cement binder to less than 0.45 helps with particularly with sulfate attack and when it comes to sulfate salt crystallization. Okay, so now let's move to question 8. It's again a true or false question. So let me start the timer now. Read to the statement and go for a timer. So the statement is during alkali silica reaction, the presence of higher percentage of calcium ions results in higher expansive gel. That is the statement. Okay. Let me start the timer. Please pick the correct option, either true or false. Time is up. Let's see the class response. most of you have picked the false. From poles, okay, here people have picked true. So overall is a mixed response. Let's see the solution. So when it comes to alkali silica reaction, so the presence of higher percentage of calcium ions, there will be the lesser the expansive of the gel formed. So with the presence of calcium ions, it does not result in higher expansive gel, it's a lesser expansive gel. So the statement is false. So moving to question 9. The question is, choose a limit of alkali content to be present in the cement to have maximum protection against alkali silica reaction. So you have to find the alkali limit, alkali content of the cement to be present to protect against alkali silica reaction. Let me start the timer for a minute now. Please choose the correct limit for alkali content to protect against ASR. Time is up. Let's see the class response. I think it's a very direct question. Most of you have picked the right answer. Oh, no one has given the answer in quotes. Okay. The question is live. Yeah, it's live, but no one answered. Okay, someone have picked option B. Let's see what's the right answer. So, coming to question 9 is also a direct question from the PPT. So, they are given you have to use low alkali cement. This is one of the strategies to protect the cement concrete against alkali silica reaction. So you have to use low alkali cement, which should be less than 0.6% of equivalent sodium oxide. So the correct answer is option B. Okay, now let's move to question 10. Question 10, there is a statement. Use of mineral admixtures such as silica fume protects the cement concrete silica fume against alkali silica reaction, because you have to find the correct reason. So there are 4 options. You have to go through all the options and pick which is the right answer. Okay, so let me start the timer now. Time is up. Let's see the class response. Okay, most of you have picked option A. Okay, one as option D. Okay, let's see from polls what answers you guys have picked. Okay, option A and option D. Let's see what's the right answer. So correct answer is option D, which means option A, B, and C. All three is right. So they have explained how does the use of mineral admixture helps with protection against alkali silica reaction. One is mineral admixtures can act in two ways. One is by reducing the penetration of water. So normally, use of pozzolanic additives, it refines the pore structure, so it reduces the penetration of water. And then second one is by binding the alkalis within the unhydrated glass, because the mineral admixtures will have some reactive silica alumina in it, which is unhydrated glass structure, which is amorphous in structure, which will bind the alkalis within the unhydrated glass. And then the alkali silica gel that forms in mineral admixtures, it also has higher amount of calcium ions. So we normally know that the presence of high percentage of calcium ions will causes lesser expansive uh, gel. So obviously in all these ways, addition of mineral admixture, use of mineral admixture helps the cement concrete against alkali silica reaction. Okay, so option D is the right answer. Let's move to question 11. So question 11 is again a true or false question. Sorry. So you have to pick the correct answer. The statement is water all the cement concrete pour freezes when temperature reduces below 0 degrees Celsius. This is a statement. Let me start the timer now for a minute. You all know that water generally freezes, pure water freezes at 0 degrees Celsius. So here you have to think the water and all the cement concrete pour will it freeze when the temperature reduces below 0 degrees Celsius. Time is up. Let's see the class response. Okay. Equal answer. One true, one false. Okay. Most of you have picked false because you have picked option B. Okay. Now let's see the correct answer. So the correct answer is false because it is clearly explained in the lecture that the freezing point in the small pores, very minute pores, is depressed to a large extent. In fact, some of the small pores in concrete freezing does not occur even under the temperature of minus 40 degrees Celsius. Because in very small pores, the ionic concentration will be higher. So also because we all know that using de-icing salts, right? So normally they use sodium chloride, calcium chloride as a de-icing salts on the concrete roads. So with which freezing of ice can be, the freezing point of water can be reduced. So normally in very small pores, the ionic concentration will be there. It further depresses the freezing point. So because of which water and all cement concrete pore will not freeze when the temperature reduces below 0 degrees Celsius. Okay. Moving to question 12. This is the last question for this week. So here is a statement. Carbonation induced corrosion is severe when relative humidity is less than 40%. Okay. This is a statement. Let me start the timer now for a minute. Time is up. Let's see the class response. Okay. Again, I could see more faults here. B. Okay. Into polls. Here, big true. Okay. Again, it's a mixed response. So let's see the solution. So most of you, if you would have gone through the lecture PPT, you know what is the critical relative humidity that influences carbonation induced corrosion. It should be in the range of 60 to 70 or even 60 to 80% of relative humidity. Even when the relative humidity is very high, okay, then the pores will be filled with water, so there is no way for the carbon dioxide to go inside the concrete. And even if the relative humidity is very less, if it's very dry, then obviously there will be no moisture for the corrosion to happen. So carbonation might happen, but the carbonation just corrosion may not happen. So the relative humidity should be in the range of 60 to 70%. Then only both carbon dioxide as well as moisture can get inside the concrete. So the statement is false. I hope you guys got it right. This is the last question for this week. So if you have any other query, you can discuss. Let me stop sharing the screen now. So me in the board. In last week, someone have asked me about something about slump, which elements will be used for measuring workability. I think that Anupama have already discussed in the last week's Tuesday live session. That's it. Most probably that's it. I think we didn't have any other query from last week. Okay, let me check the
Madam,
chat box.
hello.
Yes, sir.
Good evening. My voice is audible?
Yeah, you're audible,
Yeah.
sir.
Yeah. Very good evening. So, madam, I have one doubt.
Yeah,
Suppose
yes,
if you use a siliceous material like GGBS or fly ash,
yes, sir.
okay. So, as sir already explained that there is no, so we can reduce the carbonation up to some extent. Okay. Then,
Carbon dioxide
we,
emission, right?
carbonation. So, I think that's already shown some test, phenolphthalein and others. So we can reduce up to GGBS basically so when we add GGBS, which is responsible for the carbonation, but when we use in combination, that is a fly ash, GGBS, or any other some collet or any other material, can it be possible to reduce it up to some extent?
So when it comes to carbonation, Portland cement outperforms any other blended cements because
Okay,
there is no availability of Portlandite in
okay,
blended cements because the reactive silica or alumina reacts with the Portlandite to form additional CSH or any other reaction product. So when it comes to blended cements, obviously the carbonation resistance decreases. But if we decrease the water to cement ratio, then what
okay.
happens? The pore refinement
Resistivity
will be
of the
better.
and
The
resistance is more.
Yeah, because of the pore structure refinement, the carbonation resistance will increase. But
Okay,
in
and second thing,
general, if you go for blended cements, the
okay.
carbonation
Be-
resistance will decrease.
Because what happened here, one of our student doing one project at
Yes,
BTech
sir.
level, so he had used 50% GGBase as per the IS code. Okay, so then 50% OPC 53 grade is okay. So
Yes.
50% GGBS and 50% OPC. So one thing we have to observe that so we have to go for the RCPT test. So the chloride, of course, in RCPT we are getting the less chloride, so it is that sample get pass. Okay, so 50%. Then we have to add some calcium based chemicals. For example, calcium. That is a, we can say calcium chloride for accelerating, but actually it is going to cause a corrosion chloride. In the olden days, the people they are going to use the calcium chloride as accelerator. Okay, so we have to add calcium nitrite. Okay,
Yeah.
so this calcium nitrite, so with the help of the calcium nitrite, it was observed that after 3 days or after 7 days, we are getting increasing strength. Okay, so this pattern will be going to continue or whether it is get dropped
Regarding the strength attainment, right?
strength, compressive strength.
Uh, Sir, Like I've never read about long-term performance of concrete with
because when we do the
accelerators.
RCPT test, the sample get passed. Okay, so we are getting that as per ASTM, so that this much coulomb charge it will get passed. So
Yes, sir.
it is get passed. It will be get passed. There is no doubt. But when we compare with this, so when we prepare a control mix and when we prepare that is a sample with 50% GGBS and 50% cement and say calcium nitrate as a mineral based admixture, so whether we are going right direction,
Sir, in any way, if you are going with the SEMs, uh,
yeah,
and particularly with slag, when it comes to RCPD test, obviously it will help and your resistance will improve. And but
okay,
I can't answer your question regarding strength, long-term strength with the addition of
huh,
accelerators, right? That
yeah,
question
yeah,
I need to read and get back to you. So
okay,
because
okay,
when it comes to corrosion inhibitors, if you use corrosion inhibitors in your concrete mix, then certain research studies have shown there is a decrease in the concrete strength
okay. When we add corrosion inhibitor, up to
inhibitors.
what percent we have to add, madam?
So that
One,
I'm not so sure about
okay,
the
okay,
percentages right now, but if we go through the lectures, I'll be able to get back to you. Let me note it down for the next week. Anyway, next week there is one live session. Let me try
okay,
to add this in the PPT. Long term
okay.
performance with calcium nitrate, right?
Because durability is one of the most important factor. Or can it be possible to use any like any chemical like a PVA? Because there are some research paper in that particular thing. The people they have to work also PVA, that is a polyvinyl alcohol. So they are going to add up to say 5%, not more than 5%. So they are going to increase from 0.51 like this. So can it be possible to add a PVA for durability aspect, or can it be possible to add a calcium nitrate for durability
So
aspect?
PV
Which
in
one
the
is better?
sense for what you're adding it,
Polyvinyl alcohol.
for what
So
you're
people,
adding it.
we have to add in powder form.
No, sir. For what performance you're adding it? We know that calcium nitrate is an accelerator.
So PVA basically PVA is a, we can say for corrosion resistance. PVA shows a good result,
Okay.
especially for the chloride.
Okay, sir. Let me corrosion resistance for against chloride, right? So let
Or
me
even though we can add some, can it be possible to add some coagulant? Just like in water treatment, we are going to add some polymer type coagulant. Okay. So in our concrete, we are having PCE type that admixtures. You know, when we talk about the water and wastewater,
yeah.
we are having some
Normally we yeah,
coagulant.
it's a third generation water reducing
Uh,
admixtures. Yeah.
so can it be possible to add such kind of a thing so that
Yes,
we
sir. We
can
can
reduce
use
chloride and sulfate, especially sulfate attack and chloride, because in chloride that we are getting, if you use a polymer, then there are some research paper they have to show that we can restrict up to some level.
okay. Sir, I have never done
Okay,
any
okay,
research or
okay.
any, have read
No, thank you,
exclusively
madam.
about this, but when it comes to sir, sulfate attack and then chloride attack, uh, water reducing admixtures will not help you directly, but if you use water reducing admixtures like PCA, we can effectively reduce the water cement ratio. So
Okay,
in that way, you can refine the pore structure better. So in that way, it will help you against sulfate attack or chloride attack. But when it comes to calcium nitrate is also a corrosion inhibitor, so obviously that will affect your strength attainment. So when
okay,
you're
okay.
using a corrosion inhibitor, we have to check the concrete for long-term strength before using it in the
Main thing
concrete.
that after 56 days or after 20, because when you use GGBS, after
Yeah.
28 days, the strength is essentially important.
So particularly
So,
with corrosion inhibitor, we
uh,
have to check for the strength, then only we can proceed. That is there.
okay,
That
okay,
test we have to do. That is there. But I am not sure about this polyvinyl alcohol. That
okay,
maybe I have to read about it. Next class, let me try to get back to you, sir. Thank you.
okay, madam. And madam, one thing, last one. So, what is the tentative exam pattern, or so on which topic we have to focus very much? So, can it be possible for you so to explain in the next class, because we are having the examination on 13th of October. So, basically, in that examination, is there a numerical, because it is purely theoretical, 99%.
Yes, sir, but we have discussed few problems in cement chemistry part, right? To calculate the
Yeah,
jar
yeah.
porosity. That kind, whatever is discussed in the a
A
given
class.
topic only will be asked in the question. Apart from
Okay.
that, there will be not much variation, and most
Okay.
of the questions will be objective or fill in the type, which is normally asked in the
Yeah, one question, four options, and
yeah
or that negative marking is
multiple
there.
choice question
Multiple
will
and
be there.
descriptive.
Yeah, and then you can fill in the blanks will be there.
Okay.
And I'm not so sure about whether descriptive will be there or not. And you can write it to nptl dot iitm.ac.in. I forget about the sorry. I'm not sure about the NPTEL helpline email ID. Sorry. Yeah, there is an email ID for sort of your queries regarding your exam type and all that you can
No, no.
write it
I
to
just
them.
asked you because I already gone through the NPTEL examination,
Okay,
so
sir.
I just asked you.
Okay,
That is
sir.
I don't
Let
want.
me try to
But
ask our professor and get back to you that we can do.
okay. But sir is very teaching nicely.
Yeah.
Told to the sir. So give the feedback to the
Sorry,
sir.
sir.
He is very nicely explaining, and even though the figure, the table, whatever you have to represent, so your efforts are very. So that is essentially important in that case.
Yes, sir. Thank you, sir. We'll convey this to our professor.
Okay, thank you, madam.
Thank you, sir. Does anyone have any other query? Hall ticket will the
Hello.
come on to 12th December. Sir, mostly hall ticket will reach you before the exam. If you didn't receive it by time, then you can mail the.
Dear madam, still we are not going to receive any hall ticket through the mail
Sorry,
till
sir,
date.
you didn't
So I
receive
think
your
that
hall ticket, right?
2 weeks before the examination, they have to mention somewhere.
Sorry, sir, I didn't get you.
So the hall ticket will get received before the 2 weeks of the examination.
That I'm not so sure, sir, because I've never taken NPTEL exam. I don't know when you'll exactly receive your hall tickets. If you are not so sure, you can write it to NPTEL helpline mail ID.
Okay,
Let me
okay.
just check here. Yeah, support at nptl.it. This is the mail ID. Please write to this mail IDs for any other queries.
Hello, madam.
Yes, sir.
Madam, I have a question that what percentage of that question will be asked from the assignment? Any idea that what percentage will be asked from assignment or anything?
So I don't think there will be a repetition of the questions from assignment questions. But
Okay.
you can expect the type of question as this kind of questions will be there, that we can say, but I can't say that it will be repeated again because it's already asked, right? So here the NPTEL exams are here to understand your, you should understand your how much you can understand the topic. So obviously questions repeating will not be there, I think so. uh, Let me try to get back to a professor. I don't know whether I can get answer for this question. If I get answer for this question, I'll let you know in the next live session.
Yes, actually, what happened, the syllabus is very wide and the time duration is very low. So there is some basic idea that what type of question will be asked and how need to prepare it. So that's why I have that doubt.
Okay, sir. So please go through the assignment question, the practice assignment questions. That will help you to brush up the basics, and then mostly the questions will be similar to the questions asked in the uh, current assignment questions.
Okay.
Yes, sir.
Okay, madam. Okay,
But I don't
thank
know
you.
the weightage of the final exam. That I'm not so sure.
Okay, because sometimes what happened, the syllabus is very wide, so there is lots of chance of tricking or changing that question. So that type, it is very difficult for us. So
So
that's why I have.
obviously the questions will be only from the syllabus, not away from the syllabus. That I'm sure. But there will be some modifications to, like, they can't just repeat the questions what I've asked in the current assignment questions, right? That I don't think they'll repeat it.
Okay.
That is the
Madam, if
so.
you can ask this question to sir or anywhere else, so we can get idea because I think there may be some in that NPTEL there may be some criteria that this much amount of question will be from assignment like that.
That I've never heard about. Is that so? Like,
Yes, I heard it and I also searched from Google. So
okay.
that there is some criteria that some percentage will be asked from that assignment like that.
Oh, I
So
never
that's why
heard
I'm
about it.
asking.
Okay, this is new to me. Is there any norms given in NPTEL website like that?
No, madam. I directly search it from Google. So
Okay.
I think somebody has written about it. So I read that content.
Okay, so actually, like someone would have reported it in way about their experience, but it's not written in a way that this much of questions will be taken from assignment questions. I've never heard about it. Maybe if it is there or not, I'm not so sure because I've never taken NPTEL course to for examination till examination. So I'm not so sure, sir. I'm not sure about it. Sorry, I could not answer that query. Let me try to forward this question to our professor. If we get to know any updates, I'll let you know.
Okay, madam. Thank
Okay,
you.
sir. Thank you, sir. Let me end the call for everyone. Thank you for being so patient for this class.